So in the previous sort of thing, we just sort of finished putting the surface on it, and I unfortunately stopped that video instead of pausing it. So we're sort of at a point where now we got to figure out, why is it doing this weird little bend at the top? Okay, what's going on with that? So let's take a look at a few things. Okay, so first of all, let's take a look at how many. Before I go too far, I am going to shut off some of these things. All right, and so pretty much I don't want to see anything except the last rotate in the loft. So I'm going to take all of that stuff right there, and I'm going to right click and I'm going to hit the space bar and turn off the preview. So now all that the last things that I'm looking at, right, are the rotated geometry in the loft. Okay? So what we have here is a problem with the data. All right? So if we take a look at the loft that's going on here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things. All right? Does that make sense? My number slider here is set to 10. If I switch it down to 7, right, one more, or I switch it to 8, I got 1, 2, 3, 4, 6, 7, 8. Right? That makes sense? Think of those as floors. Okay, good. So something's going on. And so part of what we might want to do is to figure out, all right, do we have a discrepancy in a set of numbers? So I told you guys that you could use panels to do that. You don't even have to do that, though. For example, I could come over here and come to this geometry, and I can hold that off, and I'm going to put this back to 10 so we can have it at that consistent number, okay? So 10 floors. I'm going to come back to rotate here, right? This component ran once. There's nothing in there. Go to move, and go to the geometry, and how many points do I have? How many values? Read it. It says it right there. 10 locally defined values, right? Okay, let's go over here. Geometry. Let's take a look there. Oh, whoa. What's going on? Why do I have 11 locally defined values in this one, but in this one I got 10? So something's wrong, right? And what's happening is that in the creation of this portion of the definition, all right, right here, it's adding a value. And if you were to plug in to the rotation value, all right, you would find that the first rotation is 0. The next rotation is 1.5 degrees, right? Actually, no, you would have to do that into the, these are in radians. The last one, however, is 0.5 pi. And so we end up with 11 things. It says 10, but remember, a list in Grasshopper, the 0 is the first point. This is the ground floor. So it's putting 2 values into the last thing. So it's rotating the last thing one time, and then it's creating another rotation. So we have to remove that top value. And so what we're going to do is the thing that's feeding the step count into here, right, the range. It's not the domain, right? The domain just says that it's from 0 to 90 degrees. So the other thing is the range. And range has domain and steps fed into it. Right now it's got 10 coming in, right? There's one inherited value for one source, 10, right? Coming out the other end, there's 11. See the problem? So we have to take this value and lower it by 1. So we're going to use the subtract component that you guys have already used. So that's just a mathematical function. So I'm going to make a little bit of room right here. And what I'm going to do is I'm going to feed this 10 into A, right? Disconnect the steps here. It's the wrong button. And I'm going to put a panel, I'm going to copy this panel up and put a value of 1. So I'm subtracting 1. So now the result here is 9 values. Okay? When I feed that in, it fixes the problem. So there's 10 coming out of this grouping, right? So let me see if I can draw a line. Right here. So coming out of this grouping, there are 10 things. But coming out of this grouping down here, there are 11. And we've got to get those to match. So what we end up doing is subtracting the value of 1 here, right? And then we look at this and it says 10 locally defined values instead of 11. This is part of that data analysis that you guys have to do in order to get this program to work properly. Not to work properly, but so that you understand how it works. Okay? So I'm going to go ahead and I'm going to actually do one more thing on this video that I want you guys to be aware of, and then I'll let you sort of finish this up. Okay? All right. So there is a function, and I believe it's available in Rhino also, that's called cap holes. All right? So, and it might be a function of loft, but I'm not sure. I don't remember. So cap holes, right? Cap holes takes a brep. Now, you guys are probably going, I remember the first time I encountered the word brep going, what the hell's a brep? And I remember searching for it on the internet and not being able to figure out what a brep was. Well, a brep is a boundary representation. So, at any rate, here is that. We feed it in, and now when you look at it, you have a solid top and a solid bottom. If you bake it, right, so right-click, bake. I'm going to tell it to group it. And there it is. Okay? Any questions about that? All right. So I'll stop the video and I'll let you guys cap the holes and do the analysis. And don't just put the subtract function and subtract 1. Look at it. Find out what things are putting out 10 and what are putting out 11. Okay? And try to think of it from this perspective. The thing that was screwing up was the last rotation, right? So count the floors and count how many times it's rotating. All right, that's the end of this one. So stop.